All right, guys. Good morning. Okay, today we are doing the CIA review. So you might be wondering, what is that? Okay, CIA is basically like y'all's benchmark. They just keep changing the letters. It used to be called the QSA. But you guys are gonna take the CIA on Wednesday. Okay. CIA is on Wednesday, and then starting Friday, all of the grades that you guys do will be going into Q2. So the end of the quarter is next week. My grades are due on Thursday. Okay, which means that if you have any Delta maths or anything like that, they have to be submitted by the end of the day, Wednesday. That way by Thursday, I can have everything sort of ready to turn in. Last tutorials for the quarter are today after school, Thursday after school, and then Monday next week. So it's Mondays and Thursdays after school, but you can't stay next Thursday because I'll have already turned in grades. Okay. All right, so let's run through just a couple of each type here. And then I'll give you some time to fill in the gaps on the ones that we skipped. Then we'll do a few more together, and then y'all will work again on your own. So take a look at number 1, please. Okay, you have an f of x equation. You have a g of x equation. Okay, and you are asked to find in part A, f of g of 3. F of g of 3. So remember, you're gonna take 3 and you're gonna plug it into g first. So what is my g equation? Okay, very good. So then I'm gonna type in 3 squared minus 4. And that gives me 5. Okay, you'll get a calculator for the QSA, or the CIA. But then once I find that, I'm gonna take 5 and I'm gonna plug it into F. What is my F equation? So now it's 5 plus 1, which gives me 6. Okay, so you plug into the closer number first. Okay, outside number second. Okay, I'm gonna skip B and go on to C. Okay, C, I want G of F of X. Remember that if they leave this in X, that means that you're gonna use the formulas. Okay, instead of plugging in a specific number, you're gonna use the formulas and plug F into G. Plug F into G. All right, so let's start with G's formula. Will you read it out loud to me? What is G's formula? So now it's blank squared minus 4. And then into the blank, we're gonna put the middle function, which is F. We know that our F function is X plus 1. Okay, then we had one just like this on our last test. But remember, if it's squared, you just write it twice, times it out, combine like terms. So my X plus 1, I'm gonna write it on there twice. And then we'll times that out. Okay, first one is X times X. What do we get there? X squared, thank you. Then I have X times 1 is a 1x. 1 times X again is another 1x. And then 1 times 1 is a plus 1, then minus 4 behind that. Then from there, you're just looking to combine whatever like terms you can. So I only have 1x squared, that can't go with anything. But then what about my 1x and my 1x? 2x. And then my plus 1 and my minus 4 is minus 3. Okay, remember when you're combining like terms, okay, you would just do 1 plus -4 to combine those. Okay, don't do weird stuff like minus and negative and that kind of stuff. Okay, we're gonna do 1 from the bottom row. So if you'll come down, let's do letter B. So for letter B, we want F of G of X. Okay, notice that if they're leaving the X in there, we're using the formulas. So what is my F formula? So now it's 2 blank plus 10. And then remember that into the blank, that's where we're gonna plug our G equation. Will go right there. So it'll be root X plus 5. Okay, now, quick note, when y'all took your test on this, there was one kind of like this, where that's just the answer. Okay, here's why. I can't times the 2 into a square root. You can't distribute into square roots, which means that I also can't combine the 5 and the 10, because the 5 is inside a root, the 10's on the outside, so this is done. 2 root X plus 5 plus 10. Okay, sometimes, like on the one we just did, you can simplify and times things out and combine like terms, but sometimes you can't. Okay, and that's no problem. I think that does happen on your CIA. Okay, go ahead and turn the page, please. Take a look at number 3, letter B. Okay, it says X plus 10 over 3 is equal to Y. You're asked to find the inverse. Now, when you take the CIA, I'm pretty sure that it asks you to find this. But hopefully you remember that means inverse. These are the same thing. So it doesn't say in words, find the inverse. It says find F -1. We know though that that means inverse. So remember the steps to find the inverse are that you're gonna switch the X and the Y. You're gonna reverse the sides. So Y is on the left. And then you're gonna solve for Y equals. So if I'm looking at this equation, it's X plus 10 over 3. I'm gonna change that to Y plus 10 over 3. And then equals X. So I swap the X and the Y in the equation, and then I let the Y side come first. Okay, what do we think we should do first here? Get rid of the divide 3 or the plus 10? We should get rid of the divide 3. So if it's a divide 3, how do I undo it? Times 3. I'm gonna do that on both sides, so my 3's are gone. Then I just have Y plus 10 left over equals. And then 3 times X is 3X. Okay, last step from there, how do we get rid of the plus 10? Minus 10. Which means that your inverse is gonna be 3X minus 10. Okay, now for your review that we're working on, okay, we tried intentionally to pick questions that are most similar to what's on your CIA. So like the inverse question on the CIA is a fraction that looks just like the one that we just did. It's not the same numbers, okay, but it's not like a cubic root or like a 7th power or something random. Okay, this is designed to help you with that. Okay, go down to the next one. We have a couple of true falses. Okay, it says F and G are inverses, then F of G equals G of F equals X. Okay, remember that if they're inverses, everything is supposed to cancel out so that you get X. That is true. Okay, second thing says that if my graphs are inverses, their graphs are symmetric across the X-axis. Okay, that is not true. Does anyone remember what's supposed to cut the graph and the inverse in half? It's not the X-axis, not the Y-axis. It's the diagonal line, do you remember? Okay, so it shouldn't be the X-axis, it should be the diagonal line, Y equals X. Okay, and if you remember, we would fold our paper along that diagonal and then you would see that the graphs would match up. Okay, that's how inverses are symmetric. Okay. All right, I think we're just gonna maybe do one of these divisions. Let's do number 6. Okay, turn the page. Actually, before we turn the page, look at 5 carefully. Is there anything that you're gonna have to write in a 0 for?
X.
There's a 3 and a 5 that are missing. So I want you to go ahead and write in, it's 8x to the 6. Then plus 0x to the 5. Then 3x to the 4, 0x to the 3, 7x squared. Is there anything else that's missing? A regular x is gone, minus 2. Okay, now, should you do that by long division? Absolutely not. If you're dividing by an x plus 2 though, one of the big mistakes on y'all's test is that people would put plus 2 in the box. What's supposed to go in the box if you're dividing by a plus 2? Minus 2. Okay, so if you want to kind of set that up, make sure though those zeros have to be there or your answer is going to come out wrong. Okay, then also don't forget that your answer should start 1 power less than the original. So if it was an x6, your answer should start as an x5. Okay, because you can do that one by shortcut, I'm not going to do it for you. The next one though, you could not do by shortcut. So we'll do that one together. So if you'll write down your division, we're checking for any missing terms and it doesn't look like we have any. 12x3, 7x2, minus 5x minus 2. And then we're dividing by, that's a 3x plus 1. Okay, and then also, why can't we shortcut this? Because of which number? The 3 makes it unshortcuttable. Okay, what would I need to times a 3x by to perfectly match a 12x cubed? 4x squared, very good. So 4x squared. And then remember, I times that by both of these and I lined it up on the bottom. So 4x squared times 3x is a 12x cubed. Remember, we wanted that to happen. And then 4x squared times 1 is a plus 4x squared. Before I combine those rows, I have to remember to switch the signs. So this becomes a minus and a minus. 12 minus 12 in the front is going to cross out. What about the 7 minus 4? 3x squared. Carry down minus 5x. And then you repeat the process. What would I have to times a 3x by to perfectly match a 3x squared? Okay, just an x. Very good. Put your plus x up top. X times 3x is a 3x squared. X times 1 is a 1x. But then before I combine those rows, I have to go through and change all of those signs. So it's a minus minus. 3 minus 3 crosses out. That's always supposed to happen. Negative 5 minus 1 more gives me negative 6x. Carry down minus 2. Okay, last one of these. What do I times 3x by to perfectly match a minus 6x? Negative 2, very good. Negative 2 times 3x is a negative 6x. Negative 2 times 1 is a negative 2. But then remember, I got to flip-flop those signs, which means this goes to a plus and a plus. Negative 6, positive 6 crosses out. My remainder would be 0. Okay, your CIA is on your computer through Eduphoria. So the way that the answer looks is just like this. It's going to have a box for the quotient, and then it's going to have a box for the remainder. So you're not going to have to write the big thing with the plus and then the fraction at the end. So let me show you how you would record this if this was your answer. For the quotient box, you put this part, 4x squared plus x minus 2. And then for the remainder box, you put 0. Okay, rather than you having to write it with the big remainder fraction thing, they just have a box for each piece. Okay. All right. Last one we're gonna do for right now is number 8. Okay, it says write a polynomial of degree 3 with leading coefficient -1 with real roots at 0 and 2/3 and a double root at -1/2. Okay, let's do it. Y equals, we're writing a polynomial. I want real roots at 0 and 2/3. Let's start with 0. If my x is 0, where does it go in the equation? Do you remember? In the front, very good. So I'm gonna put x parentheses. My second one is supposed to be a 2/3, which is positive. So when I write my fraction, do you remember I do minus 2/3? Because you want it to be the opposite. So if the real root's at 2/3, I put x minus 2/3. Then I want a double root at minus a half. But if it's gonna happen at minus a half, what does the parentheses need to say? Plus a half. Very good. And then because it's a double root, we're gonna have to put a squared on it. Okay, very good. Okay, now, before we keep going, okay, we can't leave those as fractions. So if it won't divide, what do I do with the bottom number? Do you remember? Slide it. Very good. So it's gonna be y equals. This is a 2x minus 3 and a 2x plus 1 squared. Okay, so don't forget to slide any fractions. Okay, if it could divide, you would do it, but if it won't, then it's fine. Okay, the last thing that we skipped, yes?
Shouldn't that be a 3x minus 2?
Oh, it should be, thanks. I have it backwards. 3x minus 2. You're right. Okay, then last thing, I didn't put any of these in the notes that we did, but it is on the CIA that it says that it gives you a leading coefficient. Okay, all that means is that's the number they want in the very front. So a coefficient's just a number you put in the front. So if they want it to be a -1, you just put a -1 on the outside. Okay, so I'm gonna rewrite that since it looks ugly, but it'd be -1x, 3x minus 2, 2x plus 1. Okay. And there is one of those, make sure double roots get a squared, fractions, you slide the bottom, coefficients in the way front. Okay, do you feel like you can do that? All right, so we're gonna pick up on the next page at number 9, but I want to give you some time to do all the ones that we skipped from the first half, okay? And then ask me if you need help. Also, don't forget tutoring after school today. Okay, look at number 8. Let's just do the graph because I forgot, my bad. So here we go. Here's our graph. Okay, we know that we want a real root at 0, so that would be here. We want another root at 2/3, so I'm just gonna put that over here. We'll say that's 2/3. And then we need to have one more at minus a half, so we'll put that over here. Now remember, if it is a real root, that's where your graph touches the x-axis. That's what that means. Okay, which of these was a double? The double root is at -1/2. That means that this one needs to be a bounce. Okay, which means that when I hit the x-axis, I need to bounce off of it and not pass through. Yes, ma'am. On which one? Okay, hang on. We can go back and look at it. Okay, from here, I want you to count the total number of x's in your equation. So this would be 1, 2, and then this counts as 3 and 4. So I want you to cross out right here. This says it's a degree of 3. It's supposed to be a degree 4 because that's the total number of x's that you have. Now, if your total degree is 4, is that an even degree or an odd degree? 4 would be even. And is it a negative coefficient or a positive coefficient? Okay, so I have a negative coefficient and it's even degree. Negative coefficient, even degree, then do both ends point up or down? Down. So I'm going to start at the bottom. I'm going to bounce off the x-axis at -1/2. Then I'm gonna pass through 0, pass through 2/3.
Okay,
But the reason I know that it's a 4th degree and this was a typo is because when I count the x's, there are 4 of them. It's 1, 2, and then this counts as 3, 4, because it's a double. Okay, even coefficient or even degree with a negative coefficient, both ends go down. So it should look like that. Okay, but let me remind you that when you take your CIA, you can use Desmos and a graphing calculator. So if you're not sure, just type it in and look at it and see if it looks right. Okay? All right. Okay. I think it does have, I think we did it right. For this one that you said you were missing it. And then in case you're wondering, number 5, your remainder should have been 590. So if that is kind of a weird remainder, but I think on your CIA, it's kind of a big number too. So number 5, 590 was your remainder. Okay, let's do number 10. Okay, so you have your equation. It asks you to find the roots. So remember that roots and zeros are the same thing. And so to find a root or a 0, you set it equal to 0. So I have x cubed plus 9x squared. Then I think this question had a typo on it, but I have to think of what it was. This was supposed to be a 10. Will you change it? Okay, minus 10x and then minus 9. And then we're setting that equal to 0. Now, when you think about your types of factoring, we have too many terms to do an AC chart. Because I have an A, a B, a C, and a D. That's too many. So we're gonna have to do grouping. Okay, so I'm gonna put grouping on this. And then I'm gonna put the first 2 together and then the second 2 together. Out of the first 2, what can I take out of x cubed and 9x squared? Okay, very good. X squared is coming out. That x cubed is gonna leave me with an extra x. My 9x squared is gonna leave me with an extra 9. Okay, out of the second 2, what can I take out of negative 10x and minus 90? 10, very good. Now remember that if the first one is negative, you're supposed to take the negative out with it to be minus 10. Okay, pull that out. My negative 10x is now just an x. What is negative 90 divided by negative 10? Plus 9. And remember, those parentheses are supposed to come out identical. If they don't, then you know that you messed up. So I'm going to underline them and put a little check. Okay, because they came out to match each other. So my first factor, that's what we call the little parentheses, is x plus 9. And my second factor comes from what I took out, which was x squared minus 10. Okay, from here, x plus 9 gives me what answer when I set it equal to 0? Remember, it's always the opposite. Okay, so that's going to give me minus 9. Which means I'm going to come down here to my graph. That negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 would be way back here. I have to cross the graph at that spot. Okay, then I have an x squared minus 10. Remember, if it was an x squared plus 10, my other answers would be imaginary. But if it's an x squared minus, I just set it equal to 0 and solve. So let's do that now. I'm going to do x squared minus 10 equals 0. How do I get rid of a minus 10? Plus it. So I have x squared equals 10. And then from there, how do I get rid of the squared? Take the square root. Now, 10 is not a perfect square, but that's just because I messed this question up. So let's find it on your calculator. Okay, the square root of 10 is 3 point, we'll say 2. So it's plus or minus 3.2. Okay, but I'm pretty sure on your CIA it does come out to a whole number. That's just because I messed up that number when I wrote it. So my positive 3 we'll put over here. My negative 3 I'll put over here, 123.2, just like that. Okay, then from there, is your question an even degree or an odd degree? Odd, because my highest power was x to the 3. So I know that it's gonna start low and that it's gonna end high. Okay, it doesn't have to be perfect, but also remember you have Desmos, you have a graphing calculator. So if you're not good at this, just type it in and look at what it looks like. Okay, then it says to label the x and the y intercepts on your graph. Okay, we already found those numbers. This is -9. This is negative square root 10. This is positive square root 10. Okay, or if you want to put, this is negative 3.2-ish and positive 3.2. Okay, my y-intercept is right here. And if I want to find that exact value, just look at the calculator. Okay, last thing it says is to label the end behavior. Okay, remember that when you're doing end behavior, you're going to say as x goes to infinity, y goes to infinity. And what that means is that the forward end of the graph, the right end points up. Come over to this side, we would put as x goes to minus infinity, my graph points down. So that's your end behavior. That's what that means. This. Okay, and you should be able to do that, but remember, use the calculator, look at the picture. Okay. All right, you have some true false down here. I want to draw your attention to the first two. Okay, there's a question where you have to pick which statements are true. Okay, for an even and an odd, which one has to cross the x-axis at least once? Okay, think about it. An even or an odd, which of those two must cross the x-axis? Odd is correct. Here's why. If I do an even, let me draw you a little picture. If I make my even go like this, did it ever cross the x-axis? No, because since my ends go together, I could draw an even that's going to miss the x-axis altogether. Why can't an odd do that? Well, if this end has to point down, then it can't avoid it altogether. So for your true false, an even has to cross, that is false. Okay, because my ends go together, I can totally swerve on the x-axis. But an odd does have to cross at least once. Okay, the next two say that evens and odds have to have imaginary roots. Is that true or false? Either one of them could, but neither of them have to. Remember, the only way that you get an imaginary root is an x squared with a positive number. Okay, that's the only thing that gives you imaginaries, and those don't have to happen in either type. Okay, then the last true false, I'll let you read and do on your own. Okay, and even with a positive coefficient, both ends head to infinity. Okay, do we think that's true or false? Even positive coefficients, both ends to infinity. What do we think? Okay, even positive, that is true. They both go to infinity. Okay, versus for an odd with a negative, the left end goes to negative infinity, true or false? That is false. Remember, an odd degree negative goes like this. So I see that my left end shouldn't be to negative infinity. My left end is up. That's false. Okay. Next question. Take a look at, let's do the middle one here. Okay, it says determine the open intervals where F is increasing. So remember, increasing just means uphill. So I see that if I draw my little cart on here, remember, it has to go forward. I start off uphill. Then I go downhill, and then I go back uphill one more time right here. Okay, so let's write those intervals. My first interval, if it goes all the way to the left end of the graph, what would I put for this? Okay, negative infinity. And then when does it stop going uphill? What number? -6, correct. Put your little U. Where does it start going uphill again? And it stops at 2. Okay, now, of course, because the district's major exam, they don't ask you to write it like this. They ask you to shade it on a number line. Okay, which is very easy, but let me just show you what that would look like. You would start at -6. And then if I want to shade to negative infinity, I would just go all the way to the left end. Then if I want to shade -2 to 2, just like we did on the first day of class, you would just shade between them. So rather than asking you to put your increasing in interval form like we've done the whole year, they're gonna give you a number line and you're gonna have to shade the pieces of the graph that you're talking about. So we did cover this, but instead of writing your answer like this, you're gonna shade it on a number line. Questions on that? Okay, last one we're gonna do off this page is number 15. Okay, you have a calculator, but you should also recognize the x cubed shape. What shape is x cubed? Is it a U, a V, a hook, a squiggle? The squiggle. Okay, remember the U is if it's squared. Okay, so your squiggle goes like this. Okay, the 2 in the front does the same thing as a -x cubed with a +2 in the back. Okay, it doesn't matter where they write it. On the CIA, very sneakily, they put the 2 in the front, but these are the same. So now that we know that, what does a +2 in the equation do to your graph? Does it shift it up, down, left, or right? Up to right here. My normal squiggle looks like this. Will this one look the same way? What does it have in the front that's gonna flip it? The negative. So instead of me doing my 3 little dots uphill, like I normally do, I'll do 3 little dots down. And then when I connect my dots, I'll do 1 arm down, 1 arm up. Okay, but remember, you have a calculator, you have Desmos, use those and you don't have to memorize all of the shapes. Okay? All right, last page. Okay, for number 16, I don't know why they put this question on here. This is kind of ACT prep. SAT prep, that's basically what this whole page is. We're gonna work 2 examples and then we're done. So for the first one, they give you almost this exact same graph. And it says a semicircle has a radius of 5x. Now, you learned, y'all took geometry last year. What's the radius of a circle? Is it all the way across?
Halfway.
Halfway. So that means that from here to here is 5x. The whole, okay, very good. The whole thing is gonna be 10x, that's right. Then it says, find the area of the rectangle and then find the perimeter of the rectangle. So let's write down your formulas. When you're doing the area of a rectangle, it's gonna be length times width. When you're doing the perimeter of the rectangle, you're gonna just add all the sides. Okay, and so what that means is that essentially now I need to know how long stuff is. So Jared already pointed out, okay, that if 5x is halfway across the bottom, how long is it all the way across the bottom? Okay, so from here to here, we'll say that's 10x. Which means that this side up here is also 10x. Okay, then the last thing that we have to label is how tall the box is. But remember that for a circle, no matter where you cut it in half, it should be the same. So if this is 5x, what would this also be? 5x, very good. All right, so now let's do our area first. Area of a rectangle is length times width. That would be 5x times 10x. What is 5x times 10x? Very good, that is correct. Okay, it'd be 50x squared. Then for my perimeter, I'm just adding everybody up. So for my perimeter, I would do 5x plus 5x plus 10x plus 10x. And you could put them in a different order, it doesn't matter. Okay, but the 5 and 5 make how many together? 10, and then 10 and 10 make 20. All together, how many are there? 30. Do I up the x to an x squared or an x cubed? No, when you're adding, you keep that x the same. Okay, last question. Let's do number 18. Okay. And the smiley face kind of got moved, but here's what the question says on the CIA. Gives you a random little shape. It's not a smiley face, but then it comes up with an operation for the smiley face. So here's what it says. I want you to fix it. A smiley face B equals A squared minus B. Okay, so basically they're inventing their own math symbol. That means that when I smiley face two numbers, I'm gonna square the first one and then minus the second one from it. Okay, so then they ask you to 3 smiley face 4. Okay, but remember, the smiley face is standing in for an operation. What does the smiley face mean? It means I'm gonna do A squared minus B, which means in this case, it'd be 3 squared minus 4. Where your A is the number that comes pre-smiley face, your B is the number that comes after. So put that into your calculator. What is 3 squared? 3 squared is 9. Take away 4? 5. So now we have a 5, smiley face, another 5. Because do you see how we start off with the parentheses, follow PEMDAS. So we smiley face the 3 and the 4 together, we get 5. And now we need to smiley face 5 with itself. But remember, this smiley face just means a formula. That then I'm gonna do 5 squared minus 5. Because that's what smiley face means. What's 5 squared? 25 take away 5 is 1. Okay. And so for the other one, you have basically the same thing. Make sure that you do the parentheses first. Okay, and then you do that number outside the parentheses second. Okay, go ahead and try number 17. Give that one a shot. They're giving you a weird little B symbol. A awkward B equals 2A plus B. Which numbers do I awkward B first? The 4 and the 10 first. And then once you get that number, you'll awkward B it with the 3. What was your question, Karen? Oh yeah, you can, sure. So if I want 4 awkward B 10, what would I put for my equation? Uh-huh. Okay, good. 2 times 4 is 8, plus 10 is 18, right? So now I want 3 awkward B 18. And then remember, the one that comes in front still gets to be the A, the number that comes after still gets to be the B. So then I remember what B stands for. The awkward B means double the first number plus the second number. So then I'll do double 3 plus 18. And that'll give me 24. Okay? Yes.
I'm ready to pass.